Hey guys, I hope you're not tired of daily work. My name is Yashar. I work as a front-end developer at Lisk. So, what is Lisk? Lisk is a blockchain platform that is written in JavaScript and it's completely open source. All of our tools are open source. You can somehow start to develop your own blockchain-based application with Lisk, and we provide tools for you to develop it as fast as possible. And yeah, these are the agenda. We're gonna go through all of them. And this is our mobile application that I've worked on it for almost 6 months. It's written in React Native and JavaScript. And this is our mobile wallet that lets you to see all of your transactions. It sends token to others, request token from others, and so many cool other features. I'm gonna mention some of our interesting features. We have dark mode, if you, or as we call it, Batman mode locally. If you, like me, a big fan of dark mode, you can go to setting and change it. We have incognito mode. It's very helpful in terms of privacy. When you're in a public area and you don't want others to see your details or balance or how much token you have, you can activate it. And as you can see here, it blurs all the amount and your balance. And yeah, I'm happy to announce that in COVID version that we release in 2 weeks, we're gonna have Bitcoin support, and that lets you to store your Bitcoin token in your wallet. And let's get started. Yeah, we're here to talk about how to develop a iMessage extension with React Native. How many of you have ever worked with iMessage extension? No. Okay. So let's get started. Okay. How did it all start? I think at the end of 2018, we had a meeting and we realized that we need to implement more native features, especially in iOS. We came up with 4 different options that are announced by Apple. As you can see here, first one is Today widget, the second one is Siri command, the third one is iMessage extension, and fourth one is quick action menu that Apple called it 3D touch. And after some discussion and meeting, we couldn't find any use case for Siri command and Today widget, so we decided to continue with iMessage extension and 3D touch. And let's see what is the iMessage extension. As you can see here, this is the preview of the iMessage. And iMessage is an application that all of you have it on your iPhone, and you can chat with others with it. And in 2016, Apple introduced a new feature that lets developers to develop some application that can be run inside iMessage. And it came up with iOS 10. A lot of famous companies like YouTube, Airbnb, Spotify, Dropbox, and a lot of others, and also N26, which we influence a lot by the application, have the iOS extension. That, for example, with the help of the YouTube extension, if you're chatting with someone and you want to share a specific video, you don't need to open the main application, go through the search page, search it, and then go through the video and then share it. You can easily open the iMessage and go through the iMessage extension of YouTube, search the video, and press one button and you share with the person that you're talking to. It's almost the same for Spotify. And yeah, this is a picture of our iMessage extension. For example, what can you do with our iMessage extension? You can request token when you're talking and when you're sending a message and having a conversation with someone else. You can open our extension and request token. For example, we can have specify a specific amount and an address, and then send it to the person who you're chatting with, and that guy can click on the message that he received from you, and then accept your request, accept your, yeah, as I mentioned before, our application is written in React Native, and when we started to work on React Native on iOS extension, we thought that why not develop our iOS extension with React Native. And these are some features and components that we already had in our application. We had some visual components, business logic, utilities, and for cryptography, and some API clients that were all written in JavaScript and React Native. And we thought if we develop our application in React Native, we can use this component inside our iMessage extension. And then we went through the official document of React Native, but unfortunately we couldn't find anything there. And then we said, okay, let's search for third-party tutorial, because there is a huge community around React and React Native. After a while, we find this article, but as you can see, it was written in 2016, it was too old. The React Native ecosystem has changed a lot since 2016, and you know, this tutorial were written in Objective-C, but there is a new neighbor in the field that is called Swift. It's more similar to JavaScript, and we wanted to develop our application with Swift. And honestly, we tried this solution, but it didn't work. So, yeah. Then we went through the React developer portal of iOS, and we studied about how to develop our iOS extension with the way that Apple suggested. Which obviously, there are two ways. You can develop it in Swift or Objective-C. And then we finally decided that Swift is our option, and we want to continue with Swift. And so we came up with two different solutions. The first one was to develop the whole application in Swift, and second one was to develop our own bridge that let us to interact with iMessage API through the JavaScript and React Native. But both of them had advantages and disadvantages. The first option had this problem that we had to develop our component that I mentioned before again. And on the other hand, we're gonna end up with two different code bases that were written in two different languages. And every time that our designer wants to change some part of design, we have to update two different base code in two different languages. And the second option, which it was to rewrite a bridge that let us to interact with the iMessage API through the JavaScript. But the disadvantage of this one was that we weren't familiar how to develop our own bridge. We had to spend a lot of time to figure it out, how can we develop it, and how can we use iMessage API in that bridge. But the advantage of this one was that we didn't need to write all the components that we already had again in this one. So finally, see, we liked React Native a lot in our team, so we decided to write our own bridge. Now I would like to invite my colleague Altay to come on stage and explain more about the bridge. Thank you.
Hey everyone, I'm Altay. I'm working with Yashar at the same company for the same application. I'm also a front-end developer, but honestly I like Swift more than JavaScript because I just seen the good parts of it. So yeah, after we decided how to proceed, we first defined our needs. So our bridge should allow us to render the iMessage related part of React Native application within the core class, the base class of iMessage extension, which is named as Messages View Controller. And it should also allow us to update the presentation style which we'll talk about during the next slides. And we should also able to retrieve the active conversation and the participants. It's actually a set of data that contains the message, also the IDs of the participants given by the iMessage. And it should, of course, also allow us to compose a message and also handle and broadcast the UI and message-related events. I will also dig deeper on to this. So yeah, let's start with our most generic mission, is to how to render a React Native view within a native view. So I know that code on the right looks busy, so maybe I can go to the core part. Here, this is like how we did it on the Swift part. React Native has a class called RCT_root_view on the Objective-C library, and it basically allows us to like create a view object on the Objective-C side and place it to the place that we want to see it on the iMessage extension. So first, we just created a bundle URL, and it actually points out to the file that we registered or React Native application, which is index.message.js for our case. And then you use that bundle URL to initialize that RCT_root_view, and it has the module name that you also use while registering your React Native application. Afterwards, we just put that view into the native part. And this is actually how it looks on the React Native side. What I mean by registering the application is actually done by every React Native application. So you basically import the app registry module and then import the root part of your React Native application. Then use a name like that, which is very creative to register your application. So after that, we ended up with a result like this. So we are successfully able to render our application within the context of iMessage. And so first task is done for us. Then for the second set of tasks, we are going to introduce a guy called Messages Manager, which is actually like the core part for our implementation. And it actually has a link to the messages view controller that I mentioned in the previous step. And it allows us to interact with that base class so we can get and update the presentation style, retrieve the active conversation, compose a message, and do some more things. I also know this code doesn't look good, so first I will talk about the presentation style. So there are two kinds of presentation styles of an iMessage extension. The first one is compact, and the second one is expanded. So if your intention is to like complete a basic task, like picking a sticker and sending it to the remote participant, compact view is okay. But if you want to like request user to input some data by using the keyboard, you will need the expanded view. So or React Native site should be able to update those presentation styles easily. So the core part is actually like this. This is a code from the Swift side. We are exposing those components to React Native side, and this is actually a good example to like how to return data from the native side to the React Native, because since the communication between those two are asynchronous, the only way to return the data by using the callbacks or either the promises. So the first method is actually returns the current presentation style by using a mapper. That mapper is actually like, it holds the data as an enum object here, and then we just turn it to a string and just pass it to the React Native side. And also update presentation style method is doing something similar. We just give the style as a string, and then we cast it to the expected enum, and we update the presentation style. So, yeah. And here's how we make use of that methods on the React Native side. This code is probably more familiar to you. We just added a state property called presentation style, and in our component didMount method, we just retrieve the presentation style, and for the toggling between the compact and expanded view, we just written a demo toggle method, and here how it looks in action. So yep. So the first task of this messages manager is also completed. Then later on, the second task is actually return that conversation object with the message and the participants. It's actually very similar to what we have done in the first step. We just expose the methods again from Swift to React Native side, which has a callback, and that callback contains the conversation object and the message. As I told you before, conversation object also includes the participants' identifiers. So if you want to construct a complex logic in your application, like is the sender and the is the sender of this message is the current user that is using the phone, or is that user is the receiver? So you can use that participant identifiers to define those kind of logics. And here's how we made use of it on the React Native side. Again, in the component did mount, we just put that getActive conversation method to retrieve conversation and the message. Then we just keep it in our state. So yeah, the second mission is also completed, but the third one is actually a little bit challenging because at the end, we need to construct this layout to see it in our messages screen. So also in order to compose that layout, we have written and exposed this method from the Swift side to React Native side. It also looks busy, I know, but it's actually basically decoding the data we sent from the React Native side, and it's just constructing this layout. And you can actually see it more, maybe better with this way, with the JavaScript interface. So here we have our input, which contains URL. URL is the field that is sharing the data between the participants. So for this example code, we are just sending the timestamp and the identifier of the original sender. In our Lisk Mobile application, we are using this URL field to contain data for the requested amount of the LSK tokens, and also the requested addresses and things like that. And for the layout part, you can actually see, Apple provides a really good documentation about this particular part. So at the end, you will end up with a API like this, which will end up with a layout like this. So it's pretty much very predictable to see what is going to be presented on the screen when you are using this method. Yeah, here is a demo method. Yeah, for the media part, you can use audios, videos, or pictures. In our case, both for the Lisk Mobile and this demo application, we just use static images, because when you use static images, the recipient doesn't need to fetch them from a remote server, and you just can include those static images in your bundle. Otherwise, if you want to share videos or something, it will of course need some network connection. And yeah. So the third task is also completed with this feature. And we have actually more side tasks for this particular piece. And it's actually one of them is to show a loading screen when user first opens the iMessage extension. So since we are using our React Native code asynchronously from the file system, it takes some time, and we don't want our user to see blank screen while waiting for something to interact with the screen on the iMessage extension. So that's why we decided to put a loading view on the Swift side. Then we can also expose a method to the React Native side to hide and show that loading screen. So yeah, user actually sees an experience like this, first open the app, see the loading screen. Then afterwards, by using the method that we exposed to the React Native side, developers are also able to show and hide that loading screen. So yeah, that was the first side task. And the second one is to open deep links. Also for our application and for this demo, there was a case we had to show some data, but the context of the iMessage extension wasn't enough for displaying all of those data. So we had to provide a utility to allow iMessage extension to open a link which goes through to the main application. So in order to solve this, we also provided a method, and here how it looks like when you press the open URL, it just opens the main application. You can of course implement some data like ID, or if you want to show particular data, you can also include them and just directly use it on the React Native side. And for the event handling, we are using a class called RCT event emitter, and it's actually also exposed by React Native. And it's a very common pattern, and they're also using it in the development tools and things like that. So basically, the mission of that event emitter is to let the React Native side know about instant changes happening on the UI. Like when you are viewing list of messages, and let's say you are doing some tasks for the first message, and then user clicks to another message. We want our React Native site to be informed about those events and reflect the needed data on the screen. So the structure of that event emitter is actually like, first you define the event types, then you include those events in your class and inform the React Native site. So, and here's how you register to those events on the React Native site. It's nothing very different than registering to normal events in JavaScript. And yeah, here's how it looks. First, user clicks to the message on the below, and it has a timestamp different than the first one. Then the application doesn't even need to reload again. Like after tapping to the second one, it updates the URL part in the below with the second data. Yeah. And that was actually all for this presentation. But we definitely had more things to talk about. The experience that we had during the implementation part, because Xcode also requires some confirmation and some configuration, and the whole process for us took around 2 weeks to build all this. And we also wanted to share our experiences with a more up-to-date article, and we have that Meetup post. You can check it out. And supporting to that Meetup post, we also have that GitHub repo, which includes all the code snippets I show you there, and it also has more documentation in it. And yeah, this is how it looks in our production version of Lisk application. So the user 1 requests some Lisks from the user 2. And she accepts the request. We make an API call to transfer the tokens. Then you send another message to let the first user know about the transfer has been completed. And then you can tap on the latest message and show the transaction details. And we also have show more link at the bottom. If you want to have more information about the transaction, you can go to the main app by using the dip link there. And yeah, these are you can download our application from the app stores. Unfortunately, the one on the Google Play doesn't have this feature, but you can use the App Store one. And yeah, you can also approach to our team members. We have Monica there. She has paper wallets. She can provide you some paper wallets to onboard the Lisk ecosystem very quickly. And yep, thank you.